I think that the most important thing that users need to know about encryption is that encryption needs to have a unique key, and that key should be difficult, impossible ideally, to guess. If I had to narrow encryption to everybody, for everybody, that the one thing that I need to understand about it, it needs to have a key. That key needs to be unique and impossible to guess. It has to be your own private key. Well, in these days, we have 4096-bit keys or 256 AES keys. It depends on the encryption algorithm that's being used. But imagine you have to guess 4096 characters, alphanumeric, uppercase, lowercase, numbers, including punctuation plus question marks, and all the characters on the keyboard. And you have to guess the 4096 sequence of them. The combinations are astronomical. You are not going to be able to do that with traditional current technology. This key, essentially, because it's so big, it becomes a file that includes that string, that very, very long string, and it's non-guessable. Now, I think I would really want to add something to this, and that it has to do with encoding and the differences between encoding and encryption, because this is a common mistake, and I'm going to take the opportunity to address it now. So the one thing that makes encryption special, and again, the only thing that you need to know is you need to have a private key connected to it. That private key will be used to decrypt the data that it's addressed to you. Encoding is not encryption. If I associate A with 1 and B with 2, or if I associate A with 10 and B with 11, and follow up on that logic, and I'm going to have the alphabet mapped to numbers or whatever, that's called encoding. If I associate 2 taps on my hand with the word bird, and if I associate 3 taps with the word mouse, that's encoding. And that's actually heavily used in everything. It can be used to exfiltrate data through flashes of light, through sounds that the speaker makes. And I wanted to emphasize that that is not encryption, that is encoding, because it's reversible and predictable. It doesn't have that private key that I was talking about that prevents you from reversing the process.
The first way that attackers would attempt to work around encryption is by compromising one of the ends of the conversation. Since the information between you and me is now encrypted, and cyber criminals are very unlikely to poke a hole in the encryption protocol, they will try to compromise either my end or your end where the information is decrypted before being presented to us, right? In the real world, this happens with malware that infects either laptops or mobile devices and attempting to siphon information as it is decrypted and presented to us. Think of a piece of malware that reaches our computer and reads our usernames and passwords from the browser, not as it is being sent to the server, right? They still have access to that information because on our end, it is decrypted. Secondly, and this is a real challenging issue with the encryption on the internet, ever since organizations and technology providers have pushed encryption into the mainstream, more and more governments or law enforcement agencies have found themselves unable to collect evidence or to do proper surveillance of the society, right? Proper between inverted quotes. Most of these government entities and organizations have started to push bills that weakens encryption, creates a universal master backdoor, for instance, that would allow information to flow freely on the internet encrypted, but they will be able to somehow reverse the encryption and use that information when they need to collect information about suspects or targets.